Hello and welcome to Mathematics with Simon. I'm Simon. In the video about proving Pythagoras' theorem, I just asked the question about how you find Pythagorean triplets, and Andy Robertshaw, who's been writing on a few of the videos, suggested a method which is really good. So I'm going to talk now about how we find Pythagorean triplets. Just a quick recap on what a Pythagorean triplet is. So Pythagoras' theorem says if we have a right angle triangle with sides A, B and C, which is the hypotenuse, the long side, opposite the right angle, then Pythagoras' theorem tells us that A squared plus B squared equals C squared. For example, you could have a right angle triangle where the short sides were 3 and 4, and the long side is 5, the hypotenuse is 5, so 3 squared plus 4 squared equals 5 squared. That means 9 plus 16 equals 25. So the question really is, how do we find more? So here we have a right angle triangle where the three numbers are whole numbers. How do we find more, or all of them? Can we find all of them? Well, this is something that I noticed. M plus n squared equals m squared plus 2mn plus n squared. And also, m minus n squared equals m squared minus 2mn plus n squared. So the difference between these two is 4mn if we take one from the other. So we've got two squares here, two squared things if m and n are whole numbers. Why did I use m and n? It's always going to be a little bit tongue twisty, isn't it? If m and n are whole numbers, then we've got two squares here. The difference between them is 4mn, like this. M plus n squared equals 4mn plus m minus n squared. So if only 4 times mn was an exact square, this would be great. This would give us a Pythagorean triplet for different values of m and n. Well, 4 is an exact square, but we'd like m and n to be. So what we're going to do is, instead of taking m and n, we're going to take m squared and n squared, which will guarantee that they're exact squares as long as m and n are whole numbers. So now what we've got is m squared plus n squared squared equals m4 plus 2m squared n squared plus n4. M squared minus n squared squared equals m4 minus 2m squared n squared plus n4. So the difference between these is 4m squared n squared, which is an exact square if m and n are whole numbers, like this. So m squared plus n squared squared equals 4m squared n squared plus m squared minus n squared all squared. So this looks like it could be a Pythagorean triplet, because if we put whole numbers in for m and n, we've got a square of a whole number on the left equal to the sum of two squares of whole numbers on the right. So 4m squared n squared equals 2mn all squared. 4m squared n squared is an exact square. It's the exact square of 2mn. So for each m and n we have this Pythagorean triple. Oh, Chewy's just come in. Isn't that nice? He has a habit of coming in actually when I'm doing a video now. It's a new thing. Come on, Chewy. Let's say hello. Up you get, mister. Come on. Come on, mister. He doesn't like being left out. Look. Here he is. Here's a dog. Okay, we just had a walk today, which was really, really pleasant. So, for each m and n, we have a Pythagorean triple, m squared minus n squared, 2mn, m squared plus n squared. If m equals 2, he's got dirty wet paws. You've got wet paws. Have you been outside? If m equals 2 and n equals 1, you can put these in. So you get 2 squared minus 1 is 3, 2 times 2 is 4, 2 squared plus 1 is 5. You want to get down? Come on. So this is wonderful. So we've got 3, 4, 5. Now if we put in m is 3 and n is 2, we get 3 squared minus 2 squared is 9 minus 4 is 5. 2 times 2 times 3 is 12, 4 times 3, and then 3 squared plus 2 squared is 9 plus 4 is 13. So we can do this in a kind of serious way. We can build this table. So if we put in 2 and 1, 3 and 1, 3 and 2, 4 and 1, we can build up all these different Pythagorean triples. So the three columns on the right all describe a Pythagorean triple. So 3, 4, 5, 8, 6, 10, which is actually just 3, 4, 5 times 2. 5, 12, 13, 15, 8, 17, which is a new one, 12, 16, 20, which is actually just 3, 4, 5 times 4, 7, 24, 25, which is a new one, 24, 10, 26, which looks like double the 5, 12, 13 one. It is double the 5, 12, 13 one. 21, 10, 29, and then I'm going to 16, 30, 34, which is probably double the 8, 15, 17 one. It certainly is. And 9, 40, 41, which is new, so this is beautiful. So now, before we say goodbye, my question is to you, and I do know the answer, but it took a bit of work, it's quite interesting. Does this method help us to, does it allow us to find all the Pythagorean triples? If we just put in different values of m and n, do we get all the Pythagorean triples? And I'm going to tell you now, the answer is slightly yes and no. But that's quite a good question to ask, isn't it? Because we know that for every m and n, we get a Pythagorean triple. But the question is, do we get all of the Pythagorean triples? Anyway, anyone come back to me on that? Andy or anybody, come back to me on that. I hope you've enjoyed this. If you have, please hit like and please subscribe and hit the bell, and we'll send you more in the future. I really hope you enjoy your mathematics. Perhaps that's the most important thing. Send me your problems, send me your thoughts, and I will try to reflect on them. Chewy and I really look forward to seeing you. He's over there now on the bed. Can we see Chewy? Chewy and I really look forward to seeing you next time. Okay, bye-bye.